Today's first topic is Andromeda, something that I built in the past. I'm just making a kind of a wide stance of explaining how I built an open source Jetpack Compose design system, what a design system is, and so forth. We'll be going into a lot of details with most of these uh, small quirks that you could come across when you work with Compose, right? So to begin with, hey guys, I'm Adit. I'm one of the Google developer experts for Android in India. I'm currently an individual consultant with working with multiple companies. I have multiple clients. I get to travel a lot, have fun things to do with Android, and I kind of blog about it on my Twitter handle or on my website. You can find me on these links. There'll be links at the end of the slides if in case you want to reach out to me. There's also a public calendar that I run for 30 minutes. You can set up a small call with me, and if you have any doubts, you can definitely reach out to me. To begin with, let's take a look at what design systems are and how do we go about building it in Compose, right? But before we do any of that, let's actually think about it. How many of you actually agree to the statement, design system rules everything around me? I kind of believe that this is the epitome of everything we do in software, right? Everything has to be consistent in like like when we talk about design and the keyword called systems, we are building it in coherence with other engineers, other designers, and so forth, right? Like if you talk about a mobile app, there's so much that we do on the mobile apps, right? There's so much of content that we consume through our mobile phones, and there's so many mobile apps out there through Play Store, through various other market shares, right? Now, when I talk about design systems, it's more or less the way we connect everything together, right? It's a collection of sort of the components that you could reuse in any shape or size. It's customizable, and it kind of is driven by the guiding principles that is clearly defined in a standard practice. That this design system says you need to build this component or this particular widget or this particular text view or whatever it is in a certain way, and it should follow a particular font and so forth, right? These are small quirks of, or rather, small things that you need to take care of when you talk about design system. When we assemble it all together, that's what we could then call as a design system, and that's what we could use across a number of apps, right? Now, where do we stand today, right? Let's take a look at most of the companies would probably have an in-house design system, which would be XML based, which could be even like say many people have web apps, they have mobile apps, and so forth. Most of the design systems are actually not just generic to Android, but it's actually to anything that builds a system can be built into a design system, and you can have a library of those components that you could reuse, right? If you don't have any guidelines in the current app that you work on, or if you're working in a like a space of people, or rather a group of people that have no guidelines, but everyone is free to kind of do as they please, what happens is there's a lot of chaos, according to me. There's a huge debate going on, like, do we even need a design system? What is the return of investment? Like, if we do invest in one, how much time does it take? What is the benefits of it? So we'll be going over each of these things, and then we'll take a look at putting it all together in Compose, right? So if you don't have any guidelines for your design, let's say you're building a new app and you have a lot of things that you want to build, a lot of feature screens, or there are a lot of things that you want to reuse, right? If you don't have any guidelines, there's a high possibility that one or two engineers could drift away and not actually communicate until the post fact, until say something like a PR review, right? That's where things could go wrong. So what if we add some kind of document guidelines, like everyone has to follow this Kotlin style guide, or everyone has to follow this UI style guide? Now, these are all great as documentation, a mental picture, but it does not enforce the topic that when you build certain UI, you need to be adherent to a particular principle that the same component can be built in multiple ways, correct? Like Android is so fragmented, right? There's so many ways to do the same thing. So unless you have a documentation, it's not going to help. So this is at least stage one. Stage two of it would be, say, something like your designers coming on board and saying, hey, we have design guidelines. Figma, Zeppelin, Sketch, whatever tools you use in your organization, there's a guideline for it, and there's like a screen with, you have components over there, you have screens over there, and then you have like a style guide, these colors, these fonts, and so forth, right? So this becomes a good design guideline. The good thing about these two things, step one and step two, is that there's some sort of feedback loop in the design guidelines, but there's no feedback loop in the documentation, because documentation could be kind of written very early on, but then not updated because we are too focused on building the feature rather than actually checking if you're in the correct checkbox or not, right? For following certain principles. Very important thing during development of certain UI screens is that you have a constant UI loop, a feedback loop. When you go to your users, if they don't like a certain thing, how do you plug that data back into the next decision you make? So that's very important. Do your designers take part into those kind of conversations? So all those things are basically feedback loop. So having all this put together, these are step 1 and 2. There's another step called design system, where you can take all these learnings and you can actually implement it into a, like a framework which the designers can update and the developers can consume, and developers can build it once and then reuse it however they feel like, right? It should be customizable, right? There's a very funny way of saying this definition over and over again, but I'll still point it out. A design system is a sort of like a coherent way of bringing multiple patterns together or components together, or even in a different way of thinking. It's shared practices just glued together and put into a framework. Now, there's another one which says, wait, these are collection of reusable components, because you can develop it and then you can reuse it. Then you can bring back some modifications and then you can again deploy them. You could have one app that uses it, or you could have multiple apps that could use it. I've been lucky to work with a few companies where there is a design system in-house, and obviously XML based. Not many companies in the world are currently exposing themselves to testing out Compose, but if that day comes in the near future, there's a very convenient library that I've written, and that's what we're going to be discussing. But before we jump into all that, let's take a look at what are the pros and cons of building, say, something like a design system, right? For me, consistency, because if I can put it in words that, hey, this is how the component should look like, or this is how the theme should behave, or this is how the font should behave. If it is written or documented correctly and there's a component that behaves in that set of rules, it gives me a consistent development practice and thereby giving me a higher quality of production code, because I don't have to re-engineer, say, something as simple as having a checkbox and the text next to it that also is clickable for UX purposes, right? And thirdly, there's also a huge benefit, because now you don't have to focus on a lot of those development costs, because you're building your UI framework once and then reusing those components, and that's where you get faster builds. You have a very shared rationale. Anyone who comes to your team, whether today, day 1 or day 100, your team is growing, say, a couple of engineers in a couple of months, the design system then becomes the language where everyone can just go through it once and then see the same changes, or rather the same artifacts that are there on the design. Say something like Figma file, Photoshop file, whatever you guys use. Fourth, there's an improved maintenance and scalability factor, because, well, you don't have to touch every screen if you're just modifying one small property of a component. When I say components, by the way, these are buttons, text views, icons, like typography. It could be even illustrations that are going to be placed into your app, things that you show when, say, some error occurs, network error, right? Now, if I want to modify a version of say, a typography, like I want to change the font for the app, all I have to do is just go and update the base theme or the base design system. And because I'm a consumer, as a client of this design system, I get the benefit of that. And I can just consume it as is. Or if I have some customizations, I can go and do it locally on my end, rather than updating it on the design system, thereby giving me some control factor for the next app that I may build using the same design system. One thing that I've realized over the period is that we are able to now focus more harder on the core engineering problems than actually figure out how the UI layer works. We do emphasize on building correct and really beautiful apps, but then also building a design system gives you that control. You build it once, you reuse it, and if you're part of a company that has like a dedicated team for this such a thing, then even better, because then you have like people working on this day and night and getting you that immersive experience of building those components. You don't have to reimagine those. You just plug and play, and then that's it. And we are pretty much, that's what is needed in today's Android development, right? And more importantly, it's easy to communicate between teams. When I say teams, these are design teams. It could be a product manager, it could be even your EM and so forth, and say, hey, I have this estimate. Now, because the screen is using, say, 90% of, okay, let's be realistic, 70% design system components, it's easy for me to just dump them there and then configure certain other things during the development of that feature, and thereby reducing the cost of my development, right? Now, these are all great, but then there are also cons to it, right? There's a huge initial effort. If you don't have a design system in-house, there are multiple open source libraries out there, but then again, it's the same problem. It's not customizable. Oh, sorry, it's not customized to your needs right away. You need to put in some effort. You need to put some initial burn of testing that out, building some interfaces around it, and then seeing how it works with your apps. Or if you are trying to build something on your own for your company and you're trying to invest some time into the design system, it still takes time, right? It's also less flexible because any engineer that comes on later on, or any designer that comes on later on, there's a huge learning curve, and that way you have some flexibility issues. Whereas you could be taking that engineer or that designer or a PM or whatever role that person is playing the role of, to directly start building stuff rather than learning something, right? But the cons are, as you can see, there's two that I have kind of experienced. But if there's any that you guys have thought of, I'll be happy to see it in the chat later on, and maybe we can discuss it during the Q&A. Now, you must be wondering, all this is great, but what is my goal with this? I want to make designers and developers be friendly. I've had conversations with my designers where I say, hey, this is pixel perfect. And they say, no, this is not. You need to move it right. You need to do this. You need to do that. And when that kind of statement occurs, I am actually rushing towards building a feature. And I'm not too focused on whether the component or a button was supposed to be like 6 dp radius or 8 dp radius. I've probably not seen that. From the looks of it, I have actually feed it in 8, but it was supposed to be 6 because someone changed it. And that design is also reusable. So that means any screen that uses that particular design set is also expected to be behaving the same way. So there's a lot of back and forth. So I want to make that kind of the communication gap between the designers and the developers a little more productive. And that's what we are trying to achieve here. And most importantly, consistent user end experience, right? The users are the king or the queens of our apps, and that's what matters. So if you can give a consistent behavior of your UI and you have tested your UI properly, you don't have to actually focus on building a lot of those complexity of a screen during the development of your feature. Rather, you can invest it in during the design system time and then reuse and customize to your needs, correct? Now, how does it help, say, some of the people or some of the roles within your organization? Let's say managers, planners, EMs, engineering managers, and whatever the hierarchy of your company is. Usually, planners are the ones who are deciding how the UX flow is and what is important, when to launch it, how to do it, and so forth. They can now start focusing more on the business goals because now the UI is sort of aligned. Designers can give like a version 1 of the design. Someone approves it in the planner stage, and if everything goes right, components are pretty much the same. You don't have to rethink the engine all over again. When I say the engine, it's as simple as just strapping one of the train bogies into engine and then taking that off the station, right? Every feature is important, and because the engine is already tested, in this case, the engine is our design system, it's tested. So the next feature that I'm building, which is your train car, you can load on more users on it, and then there's a brand new feature that you could just ship out more quicker, right? Next, for designers, it also kind of improves the consistency across multiple apps, maybe multiple screens. They can build it once, and then again, reusability factor is a huge benefit for them as well. And it can also improve their productivity. They don't have to reimagine how to build a screen. Let's say you have a design team of, say, 3 people right now, and then there's a 4th person coming in, and instead of taking him or her through the process of building it on their own knowledge, you can actually show them how the design system works. A small to do kind of a guide task that you can just take them through an exercise. Once they get used to the design system, they can start building new screens, and that way more productive on the production flow, right? Also, for developers, it can help build that mental space where you can actually think about core logic rather than thinking about what the UI would do, right? I, for one, I hate building UI screens because, well, it takes too much time and effort. There's so many tools out there that Android has, and constraint layout, motion layout, there's Compose now. There's so many things that are out there. And then obviously we cannot be, if you're working on a really beautiful app, then there are obviously some custom screens or custom components. like say the clock looks slightly different, or maybe the text has some, some artifacts to it, and that is not available natively on the Android side. What if you can build a wrapper on top? That is what the design system is. Instead of you building on that, I'm actually focusing on the core logic. I could have put this effort day one, where we are building the design system, and then reap the benefits for say a year or two, and someone could then come in and just patch, say, a few things for the design system as and when the design updates or the branding updates or whatever changes on the UI, right? It also kind of brings a consistent UI for all your users, which I've already emphasized, but it also brings down the cost of QA, because the QA can actually now focus on, they can actually know that the UX of the certain button or certain component is like behaving in a certain way. And obviously it can reduce the project size, because you're reusing the components. You're not declaring multiple, I don't know, like Kotlin custom views, sorry, Android custom views, or XML, files, or even compose functions. You can actually reuse those components. Ultimately, what we are trying to achieve is something like this. The upper layer is where we are currently kicking off. There are all these white boxes with white, rim on top of it. These are the stages that usually most of the developers would go through, or a product, development cycle would look like. But if you bring down those things into, like, let's say I want to build a new feature, there's a design system, I can actually reduce down the dev effort, the QA effort, and also the designer's effort, because most of the things are now taking lesser time. Instead of you reiterating, your release is now sitting right around where the devs would actually say, hey, my build is ready for testing. So your release can also be like streamlined this way, right? Now, having said all of that, we're actually here for talking about Jetpack Compose and how to build a design system. So what are some of the things that Compose brings to the table that we could use to build a custom design system, right? Obviously, very less code, because hey, we just have to write a Kotlin function divided into, say, smaller components or smaller Kotlin functions, and that is the max that we need to do. Earlier to that, we had to work on XML, we had to work on style guides, we had to put it in like Kotlin, the Android view binding, and then connect it to, or data binding, connect it back to an activity fragment custom view, and then render everything, right? Uh, Still a lot of effort. With Compose, the code size is reduced. It's also very intuitive because it's more convenient now. The patterns that were used to build the framework of, or the thought process of that went into Jetpack Compose is actually more for customizable nature of how apps are built in today's modern world, right? This particular point, intuitive Compose gives you a lot more control over a lot of things that you would have just assumed, say, with XML, right? It also helps you accelerate development. I've actually built like some 6 or 7 Compose apps in the last 6 months for a client, and we have gone out live faster than, because what we focused on was first building a design system with some components, basic components. Did not put a lot of effort into it, but we also built a lot of the things right there, and then accelerated our development. Okay. It's also a very, very powerful framework. There's so much of extensions that you could do. Even though we're talking about a design system, it's not just for Android. It could be implied into a multi-platform stage as well, right? So you must be wondering, all this said and done, where do we start? How do we break? Like, what does a design system consist of? Let's take a look. The basic structure of a design system is, say, small atoms or building blocks or element. In this case, I've taken an example of a simple contacts app. Most of us would have used this on our phones, iPhone, Android, whatever genre you come off. The avatar picture or the image view that can render a placeholder image like that, and then if an URL is loaded, then put the photo of the person on that image and remove the placeholder, is a native, or rather the base building block or the component that is needed to build other screens. Now, this could be called element, you could call it building blocks. It's up to you. It's basically the life cycle of how uh, anything in real life would work, right? We have atoms, we go into molecules and so forth. Sorry, not a biology class, but still, or a chemistry class. Sorry. Uh, Next comes the components that binds 2 or 3 elements together or atoms together to form a shape or a definition of a component. And then that definition of a component can be reused in a page or a screen. And then that's how you get the friends tab or a contacts tab, right? A very simple breakdown analogy of how design system works. With that, I like to introduce Andromeda, a custom library that I built and open sourced it on GitHub. I'll share the links at the end of the slide for you guys to take a note of. But just to show you how things are, this is a catalog app where we have colors, icons, illustration, some typography, and some 2-3 components that we have built. This is just to showcase that you could do dark theme with Compose, you could do a light theme, how colors are going to be rendered, how icons are going to be, shown on the screen, and so forth, right? In the very crude way of looking at Compose code, this is how Andromeda works. You define a lambda. If you're not familiar with Kotlin code, the curly braces are lambda, and that's where the composable functions are then called upon. If you know what a Kotlin higher order function is, that's how Compose works. So Andromeda theme is another composable function with the annotation at the rate composable, sorry. And there's a content region where you can then draw whatever you want. You can put in your like columns, rows, whatever else. Unfortunately, this topic is not compose driven. It's more of a system design statement. So that's why I'm going to just skip through and show you how Andromeda as a thought process was built. Now, what are the design principles that I wanted to introduce into all of this, right? Always keep the user's expectation in mind, right? And always focus on the priorities. Like, what are we building first? It's okay to build, say, 2 components, and then the third one could come at a later point, right? But the first 2 components should behave. They should be very flexible. They should be very adaptable to any kind of screen. And that's what the core design principle of this library was. Secondly, the primary task. What is my primary task? The primary task was to ensure that any app that uses Andromeda or a compose-driven system, there are complications. You could use, say, something like material design. But I, for one, even though I'm a GD, I would still say this out loud. I don't like the new concepts of material view. I believe there's a lot more complications with, multiple clients who want to do some customizations in-house rather than adopt a system that is consistent across multiple. Like in today's world, it's all about being unique in the market, right? So with material design, it kind of brings them into a picture where they don't want to do that. But there are some components, obviously, from material components that we still use, but then the design component controls some factors. Those factors we'll be discussing further, but the intention of this library was to find the best middle ground. Where does how do I bring all these things together? The thought process of having components, themes, colors, write it once, and then just it applies to every screen that I use it in. That kind of a thought process, and give enough control back to the end user. Now, I'm talking as a library developer, so my end users are developers like you who would probably use this, probably will not. But still, you need to have enough controls if you ever choose to use this library and to extend it further for your own use case. That is the goal of this library, right? Now, some customization that we could do, again, I'm just picking 1 or 2 things. We'll be breaking down this further as we go down. But I could actually customize the colors, and you could have your own color schema as and how you like it. You could have support for light theme or dark theme, or you can just have light theme. You have complete control. You can also customize, say, something like a font family. There's a default provided by the library, but I wanted the app, the developers to actually have some control there as well, right? And then whatever content you draw, that will be called for you. Now, that the last line that you see, compose content with a round bracket, that's the invocation of your composable functions. You could draw whatever else you need inside, right? Now, this is where we're going to be like having some fun. We're going to be going through a lot of code, so please bear with me. There are a lot of breakdowns of how we have built this library. So let's take a look at this particular thing that we have. This is the crux of the entire library. We have a theme. You might have seen this with material theme as well, but have you actually gone and seen or realized what a material theme function or a compose function looks like? On the similar basis of what that does, we have actually written some of our own to customize to our needs, right? This is how the Andromeda theme looks like. There are a few things like shape, font family, there's colors, typography, and then the actual content. Now, you might realize there's a lambda, the higher order function at the last parameter, the content, which is another composable function, right? Now, we are using a concept called composition local provider. Now, this is very useful in Compose because let's say when you want to create a dependency in a higher node function, when it's a higher node, it could be like this. When we talk about higher order functions in Kotlin or Compose, what's happening is you're writing a function and saying, I want to inflate another function inside this, or I want to invoke it inside this function, and so forth and so forth. If you have even experienced Compose at a very ground level or a very basic example, you might have realized that we write a lot of lambda symbols or the curly braces, right? And all those functions that now are forming a tree structure, there is one or two things that will obviously be needed at the, say, at the bottommost node of that function tree, right? The top function is declaring the colors, the typography, and so forth. With composition local provider, we are actually saying, I'll provide the colors, I'll provide the typography, I'll provide the shapes. If you want to override it, I will be the root node of everything, and then you can take it from there, right? And then obviously the content is triggered. Similarly, we have a static object which would then give us colors. If you need it to be like, let's say you want to override a tint of a icon, or you want to change the text color in a text of a compose function, you could use the default theme colors by just saying Andromeda theme dot Andromeda colors dot XYZ, whatever the color could be, right? Let's take a look at what colors are, right? How did I break down colors, and what should be part of a design system for the future use cases, right? Now, colors are basically those common colors or a library of those of with consistent labels. So that you don't have to hard code certain things when you write a compose function. Say you're building a feature and then you're just hard coding, say, color.parse or something, and then you're giving a string attribute because you found it on your Figma design. You don't know what that color stands for. The intent of design system is not from a development perspective, it's also from a designer's perspective. When I say the keyword primary background, that means that it's going to be used for the background of the window or the content where the most of your recycler view, lazy column, or all the content is drawn. Secondary color could be, say, something like, one of those disabled buttons, or there's a surface where I want secondary colors to pop up. Fab, snack bar, and so forth, or even a dialog for that matter. Territory is again another third section, which could be another pop-up on top of that, right? Or you could have, say, something like a toolbar with a pop-up menu that pops open, and then I want a different color there. So you could have those predefined. As you can see, primary, secondary, and territory all have background as one of those attributes, and they then define what the color schema is. These are the default colors that are used for the Andromeda theme. You can obviously override it. How does it all look like? Well, there's this fun thing in Compose called @stable, and then we define. So it's an ordinary class. There's no @compose. @stable comes from the Compose library. What stable does is it's used to communicate the fact that I guarantee that to the Compose compiler that this class will not modulate when there is recomposition or when there is a compose state changing. Colors, you can override colors. Let's say a server data changed and you want to highlight it in red. That's the business logic of it. But when you're actually composing and recomposing on a compose code, I want it to be stable. And that's what the annotation @stable is. And then we have these funky little things that we have written: primary color, secondary, territory, border, icon, and content. Content could be your text. It could be even, say, something like a paragraph, or it could be even, some kind of the color of the illustration if you want, if you can, right? It's all up to you how you decide. Border, again, very straightforward English. Border colors are used for, say, when you want to define, say, some kind of an icon with a outline and you want to control that border color. So there's a segmented color section for that. Now you must be wondering, all this is great and well, but how do we define all these? Let's take a look. I'm using a compose, import. Sorry, I'm forgetting what it's called in Kotlin. Sorry. So I have a compose color. Instead of importing, the Android X compose.ui.color, I actually call it compose color just for simplicity, because I also have a class called color inside Andromeda, and I name them as Andromeda color, so that when you import, you don't have ambiguity. Or sorry, you do have some kind of control of which import is you're supposed to use. So what I've done here is I have fill colors, which is what is going to define how to fill into an object. Or if you talk about a button, or if you talk about, say, something like an icon, those are fill colors that you fill inside an icon or the button, the content of the button, right? And then you put your text on top, right? So these fill colors have some basic states that I feel are very important to define a design system. There's a background color. There's an active state. Let's say there's some kind of a transaction happening. A classic example could be you press a button, there's an API transaction happening, and you want to show a loading bar. That active state could be either a green or a red, depending on the state of the data, and you want to highlight it. So that active could be then used to fill that progress bar color and not touch the background color. So that's why I kept it separate. There's also an error state, which is very predominant in most of the apps. You have a content state, you have a loading state, and then the error, right? There's obviously mute colors, which you want to mute the fact that this button is no longer, or this particular component that this fill color is filling in is no longer needed, and that's where the press and the alt are coming in, right? Uh, Given that interface, we then go and again write another stable class in Compose code, which is a primary color, which extends the fill color, and then we override the values, right? There's one key important thing here is that we again define all those attributes as is, and over here we are just saying a mutable state of. So tomorrow, if I have to modify this background color during runtime, this state will be updated across the screen wherever this primary color dot background was invoked. Correct. So there is an Andromeda theme inside it. You have declared your compose components or a screen or whatever else you have declared inside it. You're using the Andromeda theme colors, and you've gone and updated it for some reason. I want to change the background color. Like let's say the dark to the light theme transition. When that occurs, I want the state to be modified across anyone who uses it, and that's why I've used a mutable state of. And for many people, structural equality policy, that's just the double equals to check that did are these two things same or not. It checks. If it is not, the color is then invalidated, and the entire wherever the screen has that color, it'll refresh that part of the component. Similarly, we have secondary colors. Like I explained before, these are very standard subsets. There's content colors, very similar policy. And if you want to customize any of this, you can then just write this function somewhere in your app module where you're consuming the Andromeda as a library, and then start customizing it however you like, right? Or you can go and modify the Android source code, Andromeda source code, sorry, right? Now, these are all colors. Now, keeping time in mind, I'm also moving ahead with typography, right? Now, typography is that common, text style, or that font that you want, or the style guide that you want all your text to follow across, every screen, and with consistent specs like font weight, font line, and so forth, right? Now, how does it all look? Well, there are some predefined fonts and predefined custom styles that are already available in Andromeda. We take each one of them, and then we can also customize how the font would behave. So we have this variable that we have declared. It's a font family where we declare the light, the bold, the extra bold, and there are some that are preset. This font is shipped with Andromeda. If you want, you can customize it and you can override it, which we'll see at a later point. But we take these fonts and then dump it into this great class called Andromeda typography. Now I have defined some basic things here. Like there are 4 titles, 2 bodies, 2 captions. You could have 10 more of variety of it. You could have, say, something like, I want a heading 1, heading 2, the HTML standard, right? For me on Android, I feel title, body, and caption are the standard practice across many designs that I work across. So that's why the naming convention is like this. The right hand side, the text style is just a composed text style. This is where this text style is sent as a parameter into the text. If you don't provide one, it's already pre-provided. And with this guy, I'm actually reusing the title hero. When I say hero, I want it to be bold and I want it to be red in color without actually taking the account of what the color of the text is, if provided at the call site. So few things like that. You must be wondering, what are these text styles, right? Now I provide a font family, and then I provide a default Andromeda typography, right? If you just want to plug and play, all of this is predefined. All I have to do is create a class, say something like this, title, hero, typography, style, put in the font family, and then get a Compose version of it. Why I do this is because then I have some more control over, say, something like this. I have an interface called base typography where I can define the font family, the size, the font weight, and the text unit, so that I don't have to write the text size is equal to 14 SP every time I want a heading, or every time I want like a caption or a subtitle, say, sitting somewhere on the card view. I don't want to be redoing those 14 SPs and all those things. I just apply the style once and then end of story, right? So very similar to how you would have styles in XML, but with Compose, you could define a typography like this. And the next point over here is something like, so now that we have like a base typography, which is my custom class from the library, we need to kind of convert it back to Compose so that Compose can then render it into a text. So that is what we do here. We go and talk to the text style, which is a Compose class, and say, hey, wait, I have this typography of my custom base, and I want to convert it to the Compose version. And that's what we're doing there. We are taking those 4 parameters and this assigning it to the text style. And this text style can then be passed into a text in Compose. If you played with it, you realize how powerful that particular function is, right? We also have this extension function, which we saw just now, which does just this exact thing. I have an extension on the interface so that I don't have to rewrite any of those, right? Now, there's this concept of local. you might see in Compose, but this is a composition local. Remember, I spoke about composition local provider before, and we had an Andromeda theme implementation detail which had some component or some local provider is providing the colors. Similarly, we have local typography. Similarly, for local colors, for the colors we have local colors. It's of the type Andromeda typography, and then if you use a text from my library and you don't wrap it inside Andromeda theme, then this error will be thrown because I don't know how to set the style, because I'll have a custom implementation of how the style should be set into a style guide, right? Again, just showing this again for convenience, we have a static Andromeda theme object where you could just declare the typography, and there's a read-only composable. That means no one can modify it. When you declare your Andromeda theme, you can actually customize it for that screen. I want only one screen in dark, everything else in light. You can do that. But if you want to read the current value of a typography, or you want to get the current colors, you would do one of these things, correct? Now, moving on, there's building blocks and components, which we are also running out of time. So I'm just going to quickly squeeze through this. There are these crafted icons that I wanted to present through the library so that you don't have to reimagine those icons. How do I get it? Material design library already has some amazing icons, .filled, .default, .unfilled. You can go to the Google Fonts site where there's icons that are already listed. You can just use them in your text, your icon, your image, whatever, right? But I also wanted to kind of control, if I want to override some tint because the theme changed, it's very difficult to go and do this on every call site where I have declared those, the material design icons. So I wanted to control some of those things, and there could be some business specific icons that I want to provide. This library could do that, and then this could be the gallery where you could go and search. You like the photos gallery, which is the second row, second column. You take that photos icon and then you reuse it. How did I define the icon? I know the code is pathetically small over here, but I'll actually break this down. This is the entire code for how the public component looks like. That is, if you're the developer consuming this as a component from my library, you would be going through this stages. I give you some customizations. Obviously, the Compose modifier is available. You can customize it however you like. There's a content emphasis. Again, if you want to kind of emphasize a content for a certain for a certain use case, I can actually override it, and then there's another local provider for that. There's also a tinting that we pre-default to like a undefined or a transparent tint, which means if you have a colored icon, I don't do anything with it. If you want to provide, you can actually tint your color, right? So there is a painter. You can also have an image vector in Compose that could be there. There's another component with the similar specs. The only difference is there is an image vector instead of painter and so forth. Similarly for the tint color, as I explained. Now going inside the function block, I have a color filter that does this exact. If the tint is unspecified, that means the default value do nothing. If there is a tint that you want to add to the custom icon function that I have, then you can provide a tint color and we will consume it and then set a color filter on top of the entire view for the icon, right? Then there is the semantics with accessibility and Android, very important. There's content description. If you don't provide one, we will associate one and we will put a basic content description, right? Small quirks that I'm trying to solve so that the end user or the end developer in this case has not bothered to go through that mental space of, oh, how do I do this? How do I do that? Where do I get this content description? What should I put here? So there is a default depending on the use case that you have, right? Similarly, we have an icon click ripple effect. There's an interaction source. If you know what Compose is, when you click on it, you get a ripple effect, and all those things can be controllable. So at the end of the day, what I'm doing is I'm taking a paint object on a box and drawing the icon so that you can, if you want, you can draw an outline. You can provide it in the modifier. I'll add it to this box. The reason why I do that is because I'm using the modifier provided from the function and not creating my own instance. The capital M stands for like a brand new instance. The small m is what you guys provide in the function of icon. If you don't provide one, I'll just default and start painting the object that you had provided, right? There's another variance of it. Like I said, there is an image vector, and then same thing. And as you can see inside the function block, this guy is now going and remembering the vector image as well. So that if in case there is a recomposition, the image is not changed, I will not redraw. There's no recomposition triggered on this component. So all the benefits of Compose, but also extended further, right? Now there are these buttons, straight and simple. I have 3 basic examples here, but the idea here is that this is vital for most of your design screens. So let's take a look at how we build this. Again, huge amount of code base, but then I'm going to break it down for you. The first set of things that you're going to be looking at is the composable function called button, which has these parameters. Most of it is border content padding. There's content which is very simple interaction source. If you want, you can provide one. Why I do this is because I want to control the elevation based on the theme, and I also want to control the colors. And if I want to add an icon on the left, which is possible because of content, anything inside a button is a complete control of the call site. But I also want to control, if you want to have a button, I can extend something called as a loading button with the loading icon already pre-present. If you want to use it again, reusable components as the highlight of the day, that component can be then reused without you actually thinking, how do I get the icon fitted inside the button, right? So moving inside the elevation ladder, right? The irony of it, there's this button defaults, which I've kind of very similar concept to what material theme also does. There are these defaults that give you, the horizontal padding, the height, and so forth. But then there's a concept called elevation where I take into account that uh, there's a chance that the button has to be flat. It's a CTA, like primary action button, or it's a secondary action button. Depending on this, some design systems would require certain rules for to behave in a certain way for the buttons. So to control all those things, these are all exposed from the outside world. Whoever uses the button from Andromeda library, but still internally there is the default state, the press state, and then the the disabled state, right? Now, what does a button elevation look like? Well, it's just an interaction source from Compose, which basically goes through the interaction. It remembers that you had interacted with the button, and then based on the state of it, if it is pressed, it'll add the interaction, the ripple effect. You can also customize the ripple effect and Compose. You don't have to go through and a Stack Overflow question. All of that is pre-provided. If you release the the touch effect, then the press is removed as an interaction. And then if you have a cancel, like if you have those talkback schemes and so forth, and if you press the cancel button, you again the interaction could be taken away, right? Again, all UX and all of this is part of the and part and parcel of how design system should work. Again, just coming back to the button, how did we do the button? Well, very similar to material theme. We built a surface and then we started providing a row where everything is drawn. So ideally what you do is you take a button and you have a row and you can put anything inside it. It's a horizontal row, correct? What we are doing here is we are setting a minimum height and width so that it's also protocol followed, right? The button should not be smaller than a certain thing. Like if you have a text that is like overflowing from the button, those are already controlled inside this implementation detail so that I don't have to do this over and over again in every screen, right? We take that row and then put it inside these providers, which basically emphasize, if I had provided an emphasis that I want this to be like a alert button, irrespective of what the primary color of the button is, I want it to be alerted now. Like the network failed and every button is now with a yellow borderline. That kind of a logic, if you have to build, you could use something called as a content emphasis, and that's what we're doing here. And obviously, I have my own typography, so I'm providing that inside the content emphasis, and then the row is drawn. So if you have any text, the text, if you pass an Andromeda typography object or a text style from the Andromeda library, it will be consumed because we have given a default as title moderate. Okay. Moving on, shapes, very straightforward, nothing too complex. We have two interfaces that just give you basic shapes that you could then just define as these defaults. Why we do this is so that people don't have to go and rewrite all of this. Like bottom sheet, I want rounded corner status, like the top left and the top right should be rounded with certain pixels, 16 at this case. So this is pre-provided. You can obviously override it. And there's the button shape, dialog shape, and so forth. There's so many things that you would anyway come across. You can all have those shapes predefined here in a generic place and then reuse it in any shape and size as and when required. Same with the composition local. Your theme needs to provide it, and this is the provider, and this is how the dot gets connected back. So the theme then says, okay, there's this Andromeda shape that I need to use in, say, a button. Even the buttons that are there in Andromeda have rounded corners by default and elevation of 2 dp. So all those things are small quirks that are then provided like this. To kind of go through how the code structure is, this is how the components are built. There's a package called components, very straightforward. There's a foundation library that provides color, shape, some tokens for the colors, and then the actual Andromeda theme, right? Now you must be wondering, oh, this is great, but show me the results. Like, how does it look all together? Now, this is a slightly complex example, but I'll just quickly go through it. Now, what I've done here is I have a set content, which is what you do in your the app compact activity or a fragment or whatever else you use, you define set content. Then inside that lambda, it's a composable function. You declare your composable theme inside it. Then you start building your nav graph or a screen component or some basic text or whatever else you're trying to do. So what we have done here is we have used window insets and so forth. Not too relevant right now, but I've also taken Andromeda theme and customized it for a particular catalog app, which is all again open source. You can take a look. If you want to customize the theme and you only want the light theme and you want to override the colors, you could do that by writing that catalog theme is light theme is equal to the object that you're trying to override. And if you want to override the fonts, you can provide your own fonts, and that screen will use whatever fonts you provided. Everywhere else you use catalog theme will use the default Andromeda theme. How does it all look? Well, catalog theme is another composable function that inflates the Andromeda theme inside and then calls the content for you. That's all, plain and simple. Over here, I have a different fonts family set, the catalog black, the catalog bold, and so forth. And that's what I'm like putting it all back together. Now, to take a look at results, what have we actually done? If you kind of want to scan out and not look at any more code, this is what we have done. In Compose, there is this runtime library, there is the UI side of things, then there's the foundation on which text, icon, and all these things come. And on top of it is the material design, which adds the design system rules on top, which then can be used. What we have done is we have built another design system on top of it. You could be using some certain things from material design, but with Andromeda, I've just kind of muted it to the bare minimum. Maybe one or two things, maybe the icons, which is again a separate artifact. You can simply just bring that in with Andromeda and all your icons and everything else is available. With that, these are the GitHub repo for this particular library. There's also a catalog app on the Play Store. You can go and check it out. If you have any feedback for it, I'll be happy to address those on the chat or offline, or we could be doing back. Once the stage is over, we'll go on a table and we can discuss there. If you're curious, what are other design system libraries out there? There are quite a few. There is Plaster. There is this website called Design Systems, very, very friendly. There is awesome design systems like GitHub repo, which kind of emphasizes on multiple of those libraries for Android and so forth. And then there is the Skyscanner backpack, which is one of the best out there, in my opinion. With that, folks, that's it. Thank you so much. Sorry, I went overboard with the time. If you want to reach out to me, there is my calendar link. You can raise a 30-minute conversations with me. It could be fun things. It could be about beer. It could be coffee. It could be about Android or Compose or Andromeda. With that, thank you so much. Over to you, Shalom.
Audible clapping while everybody else has to use the reactions. Adit, that was amazing. Good. Thank you so much. Okay, so before giving too much praise, since it went over a little, what I'm suggesting for the group is let's give everybody a couple minutes to put questions in the Q&A. However, we're not going to answer them now. Since instead, we'll take a 5-minute break after the questions are all added in, and then we'll start Anna's talk. Afterwards, Adit, if you have time, you can just have a table, look at the questions and run through them, and whoever wants to be at the table with Adit can listen.
I'll do that. Yeah. Thank you so much. Sorry for the overtime, but yeah, hopefully I was able to break it down. Yeah, cool. Right. Thank you. Bye-bye.